Hey guys, take a look at this old tin can of sodium amide that I managed to find. Sodium amide is an extremely reactive and hazardous substance that requires strict adherence to safety precautions. But what interested me the most is the following. On the Wikipedia page about sodium amide, it states that in the presence of peroxides may form. This is accompanied by yellowing or browning of the solid. As such, sodium amide is to be stored in a tightly closed container under an atmosphere of an inert gas. Sodium amide samples, which are yellow or brown in color, represent explosion risks. To be honest, I don't think we'll be able to find any traces of those yellow or brown dangerous peroxides in such a tightly sealed can. I've broken the seal. Now let's see what condition the sodium amide is in. Good sodium amide has a noticeable ammonia smell in air, but these caked chunks don't look like a reactive chemical at all. I'm sure it won't even react with water, but we still needed to check. There is absolutely no reaction and no ammonia smell, just barely noticeable bubbles. Even if I bring a piece of damp litmus paper close to it, there is no color change, nothing like what you'd see if ammonia were present in the air. Write in the comments what you think sodium amide has turned into after such a long period of storage. But before you share your thoughts, take a look at its reaction with nitric acid. The second old tin can turned out to contain lithium amide. Even though it's old, the packaging looks intact and reliable. Let's open this can. The lid of the can even shows instructions on how to do it properly. This reagent looks much more promising. It also has a slight ammonia smell. Overall, lithium amide is less reactive than sodium amide. So if we add water to it, it reacts just like for sodium amide without the release of ammonia but without ignition. Ammonia will also be released actively if we add dry ammonium chloride powder to lithium amide. The indicator paper quickly changes color to one characteristic of an alkaline reaction. If a lot of ammonia is produced during hydrolysis, then reacting it with hydrochloric acid will generate a lot of white fumes of ammonium chloride. Nitric acid, unlike hydrochloric acid, can ignite lithium amide. Liquid nitrogen dioxide can do the same thing. Lithium itself burns with a bright white flame, but if you direct a stream of ammonia at it, it will start burning with a red-orange flame, forming lithium amide. Lithium, like other alkali metals, can be dissolved in liquid ammonia, forming a so-called blue solution of solvated electrons. If after some time the ammonia is evaporated, Of course, in the absence of moisture and under an inert atmosphere, you can obtain lithium amide. By the way, concentrated nitric acid can ignite a solution of lithium in liquid ammonia. Now let's drop another piece of lithium into liquid ammonia and wait until the test tube turns almost completely blue. Now I'll insert a glass tube into this solution and start bubbling carbon monoxide through it. Pretty soon the blue color of the solution disappears. This happens due to the formation of lithium acetylene diolate and lithium benzene hexolate. These compounds were once mistakenly thought to be lithium carbonyl. For our next experiment, I'll put a small amount of lithium amide into a test tube and heat it slightly. Then I'll place a magnet above a test tube. Next we'll need iron pentacarbonyl, which I'll add drop by drop to the heated lithium amide. As a result of this reaction, very fine particles of metallic iron are formed, which immediately get attracted to the magnet as they leave the test tube. However, due to the strontium hood, not all the iron particles manage to get attracted to the magnet. When I filmed this reaction, in one take I added quite a lot of iron pentacarbonyl at once, and before it could decompose, it evaporated from the test tube and its vapors ignited. So I decided to include this shot. It seemed really interesting to me. So guys, I hope you enjoyed the video, an idea for which came to me as soon as I found a couple of old cans of sodium and lithium amide. I hope you learned something new, and I'm really glad I was able to put them to good use. I'd also like to give a huge thank you to all my patrons. It's thanks to you that this channel lives and grows, and that new videos keep coming out. Without you, this channel wouldn't exist, and I wouldn't have the opportunity to create new content for all of you. So if you have the opportunity, please consider becoming my patron. It's critically important. Thanks for watching, see you in the next video.